In this example, we're going to go back to a previous one. I believe it's from 9.2, maybe B notes, example 1. And this will be a little bit later here, but we're going to go back to that example. We're going to be comparing the body fat percentage with waist size and also the weight. In this case, what we're going to do with the first one is we're going to perform a linear regression in our calculator. We're going to use the waist size, which is L1 here, and body fat percentage, which is in L3. Now I've already entered my data in. Check out a past video if you need to know how to, if you need to learn how to do that. And I've entered it in appropriately with list 1, list 2, and list 3. And let's see if we can go back here and graph this. So I'm going to go to second y equals. My plot 1 is turned on. It's on scatter plot, and all you need to do is just cursor over it and hit enter. And then I have list 1 and list 3 here. So to get list 1, you just hit second 1, and to get list 3, you just hit second 3 on your buttons there. You can change the mark if you want, it doesn't really matter. And I'm going to go to graph here, and you can see what this looks like. What we want to do with this one though is actually find the linear regression, the best fit line. So I'm going to go to my statistics button, STAT. We want to calculate, so we'll go 1 to the right. And we want the linear regression number 4. So you can just hit 4 or cursor down to 4 and hit enter. The calculator needs to know which lists we want to compare. The default is list 1 and list 2, but we want list 1, comma's right here, and list 2. So we'll hit second 2. The calculator will be fine with this right here. It'll calculate everything for you. However, what we want to do, or what I'm going to show you actually, is what it looks like on the graph. And we're going to ask the calculator to store this in y sub 1. So let's hit another comma. And we're going to go to the variables key, which is right here, vars. We're going to cursor 1 right to y variables. We want the function variables. We'll hit enter, and we'll hit enter again. What we're asking the calculator to do for us now is look at the data in list 1, and boy, I almost made a mistake there. That should be list 3. Gosh darn it, right? Always go back and make sure your data is in the correct list, or you're using the correct list. List 1 and list 3, and then y sub 1. We're going to have the calculator stored in that value, or in that piece. So we're given a bunch of stuff here. The calculator has given us the slope, which is about 2.22. And then also, we have a y-intercept of negative 62.56. R squared is 0.7865, and we're going to list that as a percent, so that'll be about 78.7%. R is 0.89. All right, what does R squared mean in this situation? That's a question that we have to answer. Stand by here while we reset the paper. Okay. So what does R squared mean in this situation? It means that 78.7% of the variation in the data is accounted for by the model. What does R mean in this situation? Well, R is positive, so there is a positive relationship or positive slope. As x goes up, so does y. That's what we mean by that. And it's close to 1, so we would say that the 0.89 would indicate that there is a strong relationship. You could say strong correlation here if you wanted to, between the variables. What do these pieces tell us about using a linear model for this data? Well, we looked at the data in the graph. We saw that it lined up in a line. And it seems like that with a 78.7%, which is a decent amount of the variation accounted for by the model, and there indicate a 0.89, and our value of 0.89 indicates there's a strong relationship or correlation. So we would say that a linear model is appropriate for this data. Okay, so we've got that down. And what we're going to do is we're going to do the same thing, but this time we're going to do something a little bit different. We're going to use the data, we're going to switch one of the pieces of data, I should say. And so we're going to use the weight, and the weight is in list 2, body fat percentage is still in list 3. So let's see if we can do that here. I'm going to show you the graph of that data. It's really good to look at the graph. If you're using a linear regression, the data better be linear. If it's not, the calculator will still calculate it, but you're going to be way off. So let's see here. We've got list 1 for the X. We want that to be list 2, so I'll hit second and number 2. Then I'll hit zoom 9 here, and there's a look at the scatter plot of the data. There it is right there. Well, let's see if we can calculate some things. It looks roughly linear. It's not curved or anything weird like that. So we're going to go to our statistics button, cursor 1 right to calculate. We're going to go down to number 4, hit enter. This time we're going to do list 2 and list 3, and we're going to ask the calculator to store that in y sub 1. So we'll hit enter here. Okay, and if you hit graph, actually the thing will, calculator will graph it for you. I forgot to do that for the last one, but you can see that best fit line here. Okay, but anyways, we'll get back to the screen right here. So there's our data, and we want to list the A value here. It's 0.25, so that's the slope, 0.25. B for this one is negative 27.4, or if we keep with our rounding here, it's going to be negative 7.38. The R value, or excuse me, R squared is 0.485, or 48.5%. And the R value is 0.70 if we round up a little bit. What does R squared mean in this situation? Well, R squared is still the percent of variation accounted for by the model, so we would say 48.5% of the variation is accounted for by the model. Not great. What does R mean in this situation? R is 0.7, so I would say that there is a positive, meaning as X increases, so does Y. Positive moderate correlation. You might call this strong, but this is kind of borderline. I would call this moderate. What do these pieces tell us about using a linear model for this data? I would say a linear model is still appropriate, and our value of 0.7 is not too bad, is still appropriate, but might not be the best. Which model is better? Okay, well, that's the question here at the bottom. So let's take a look at some things that we discovered before, and we're going to look at that R value and the R squared value. So if we look here, hope you can see that there. Let's see, that should be good. Yep, you can barely see the R down there. So anyways, for the first one, R squared was 78.7%. For the second one, it's only 48.5%. Also, R is 0.89 for the first one and 0.7 for the second one. So it seems like waist size and body fat percentage are more correlated than the other one. So what we'll do here is we'll say which model is better. Well, it seems like waist size versus body fat is better, and more variation is accounted for by the model, and there is a stronger correlation. So we're looking at the R value. R is 0.89 compared to 0.7, and you could list that variation here for the top as well.